96% of our universe is missing. Our galaxy should have already been colonized by aliens 1,000 times, and the solar system might have a hidden 9th planet that is 10 times the size of Earth. These are my favorite real space mysteries, so get ready. This mystery is my personal favorite and is remarkably simple. It can all be boiled down to just one question. Where are all the aliens? This was the famous question that Enrico Fermi, the nuclear physicist, asked while working at Los Alamos National Laboratory over lunch. The story goes that Fermi and his colleagues were discussing these recent UFO sightings that had been showing up in the news, when Fermi suddenly asked, "Where is everybody?" And the room fell silent because no one had an answer. And that is the great paradox. Our Milky Way galaxy is 10 billion years old and 100,000 light years wide. Now, if aliens had spaceships capable of traveling even 1% the speed of light, the galaxy should have been colonized over 1,000 times already. And yet we haven't heard from or detected any other life. Why? One of the best solutions to the Fermi paradox was given the name the Great Filter. This is some evolutionary wall impermeable to most life. This of course raises the question, is this wall behind us or in front of us? If it is behind us, maybe the filter is the creation of life itself, or even the jump from single-cell prokaryotes to multi-cell eukaryotes. If it is instead ahead of us, we haven't heard from any aliens because they must have hit this wall and ceased to exist. This of course implies that one day our time will come too, and we will hit the wall and cease to exist. But maybe the explanation is actually simple. Maybe the entire universe is actually colonized and capable of communication, but we just happen to be stuck in a desolate area far from all the activity. Or maybe there are just these hyper-advanced civilizations that just don't care about communicating with life so much more inferior to them. Maybe to them we are just another ant mound because they are so much more advanced than us. Or maybe interstellar travel is just too expensive and energy intensive. So let's say that you want to send people on a spaceship to the nearest star system to us, Proxima Centauri, and you wanted it to arrive in, say, 50 years. It would require 150 billion joules of energy. That would be about $40 billion per person on board. Or maybe, just maybe, the evolution of single-cell life to where we are today is just so unbelievably rare that it only happened once in our galaxy. The problem is, no one has the answer. That's where the mystery comes from. And I'm not sure why we haven't found aliens yet when the numbers suggest we should have by now. And maybe we'll never know. Look at this galaxy. Do you notice something strange? You can't see it, but what if I told you around 80% of the mass of this entire galaxy is completely invisible? All the beautiful light you can see, the stars and gas shining, that is just 20% of the galaxy's mass. So where's the rest? This is the mystery of dark matter. You see, scientists are sure that a huge percentage of our universe is made up of this invisible matter, and yet we can still feel its gravitational effect. Back in 1933, there was an astronomer named Fritz Zwicky who was observing a huge cluster of galaxies. He noticed that a number of these galaxies in the cluster were orbiting much faster than they should have been given the mass. And so he suggested there might be an exotic form of invisible matter called dark matter inhabiting the cluster. And then in the 1970s, Vera Rubin and Kent Ford unveiled their own theory of dark matter. The idea comes from a few mysterious observations that just couldn't be explained by the theories of the time. They noticed something weird. Stars that were orbiting galaxies far out at the edge were orbiting at pretty much the exact same speed as those near the center. This goes completely against Newtonian mechanics, which says the stars further out should be orbiting slower, as more stars and gas near the core should provide the additional gravitational force required to speed them up. So how can this be? Well, Rubin and Ford went on to argue that every single galaxy is completely engulfed in this halo of dark matter. This provides the additional mass required to explain this strange observation. Now, they believe that dark matter accounts for around 85% of all of the matter within any galaxy. That is a ridiculous amount of matter that we know very little about. And so there are two main ideas that are being explored right now. Either dark matter is some kind of particle that doesn't interact with light and can only be detected through its gravitational effect. Or maybe our theory of gravity is wrong, and we need a revised theory. Now, I would be willing to bet that a dark matter particle is the real explanation, and we will have made some serious progress at a detection within the next 20 years or so. But for now, it remains a mystery. Okay, I'd just like to take a quick moment to thank the sponsor of today's video, Opera Browser. Now, this is not just any browser. It has so many features that are genuinely so useful that I can't believe I was using the internet without it before. Now, if we're talking security, Opera has a free built-in VPN, ad blocker, and tracker blocker to keep you safe while browsing. You can also pin apps like TikTok, Twitter, and Instagram to this sidebar, and they even have this feature that lets you group tabs together. Now, I personally have been using this to have a group for my university work separate from all the random stuff I find myself opening to keep things less cluttered. And I haven't even told you about the coolest feature yet, Aria, Opera's built-in AI. You can ask Aria questions to have it explain stuff from the website back to you at any point, and it's actually connected to the internet, so the information updates in real time. I've even started just using the music player to play Spotify from within the browser. It's actually super handy, and it works for all of the major music streaming services. So if you want to try out this awesome browser completely for free, just click the link in the top of the description, and in doing so, you are supporting the channel. Astronomers discovered the last of the main planets in our solar system all the way back in 1846, but some would argue there is another planet waiting to be discovered. And I'm sorry to say, I'm not talking about Pluto. According to the IAU, Pluto is stuck as a dwarf planet. In the outer regions of our solar system lies the Kuiper Belt, a sort of donut of frozen objects that encapsulates our solar system. And I'm not talking just a few rocks. You see, there are hundreds of thousands of objects larger than 100 kilometers in diameter and up to 1 trillion comets orbiting out there. This is where Pluto lives, and so scientists wondered, what are the chances that Pluto is the only relatively large object out here? Maybe there are others that we just haven't found yet. And that's when they started finding a number of these strange dwarf planets out there. It was these detections that caused Pluto to be demoted to a dwarf planet. Now, one of these dwarf planets named Sedna appears to be around 40% the size of Pluto, but it had this really strange orbit. Instead of orbiting in a nice flat ellipse with the rest of the planets, it appeared to take a strange and unexpected path. For you to understand just how weird it really is, you need to understand the astronomical unit. That is just the distance between the Earth and the Sun. It's just a really nice reference for distances in the local solar system. Now, Sedna was swinging from just 76 astronomical units in the center of our solar system out to more than 900 AU, over an 11,000 year period. I mean, the last time Sedna was at its current position, humans had only just figured out how to farm. It's like something really big was out there pulling Sedna away on this strange orbit. Enter Planet X, a theoretical planet between 5 and 10 times the size of Earth, hidden in the dark depths of our skies. And Sedna wasn't the only strange object. There were 6 others, all being pulled in the same direction, each tilted in its axis in the same direction. And this number of strange objects continues to climb, now approaching 20. And so, if they think this massive planet is just orbiting out there, the question becomes, well, why haven't we found it? You see, the problem is when we look out into the universe using these huge telescopes, we often aren't looking for just one specific thing. Instead, we are doing these big surveys of the entire night sky to capture millions and billions of individual objects. You have to remember, there is only a really tiny portion of the sky that would contain Planet 9. And at the moment, there is just one telescope, the Subaru telescope in Hawaii, that's capable of capturing the weak light from the distant celestial objects. However, there is a new telescope being built in Chile, the Vera Rubin Observatory, that some astronomers believe will be the key to finding our solar system's long-lost sibling. If we still can't find the planet, there is another alternative that's even more intriguing. Some astronomers have suggested that the weird gravitational effect might be caused by a rogue, primordial black hole in our outer solar system. Now, these primordial black holes have never been observed, but they are thought to have been born in the hot universe soup just after the Big Bang. But regardless of whether it's a black hole, a mysterious missing planet, or even just an error in our math and observations, I'm confident that we will solve this mystery in the coming years. The universe is expanding. You may have already heard that before, but did you know that this expansion is actually getting faster? Let me explain. First, I want you to imagine that you throw a ball up in the air. It obviously slows down as a result of the Earth's gravity pulling on it before stopping mid-air and falling back towards the Earth. Now, I want you to imagine that you throw this same ball into the air, and this time, instead of it falling back to the Earth, it flies away from Earth into space, getting faster and faster as it goes. Now, this is what scientists have been watching happen to the entire universe, and they aren't entirely sure why. The period luminosity scale, first developed by Henrietta Leavitt, allowed us to calculate the distance to variable stars. Now, using this scale, Hubble looked far out to the Andromeda Galaxy, a galaxy containing a variable star, and found that it was more than 900,000 light years away, far beyond the reaches of our own Milky Way. Now, this was quite a revolutionary discovery at the time, and it wasn't long until Hubble observed many more galaxies and he noticed something strange. He measured the distance to 23 other galaxies, out to a distance of around 20 million light years, and noticed that those galaxies further away appeared to be more redshifted than the galaxies closer to us. This redshifting occurs as a result of the Doppler shift. In this case, the light waves are stretched out as the galaxy moves away from us, causing it to appear more red. Now, in doing so, Hubble was able to show that the objects further away from us were moving away faster than those closer. Hence, the universe must be expanding. This discovery is often attributed as the biggest astronomical breakthrough in the entire 20th century. Now, I want you to imagine that you are an astronomer at the time, and you've just learned that the universe is expanding, getting bigger every second. Now, what do you imagine happens to this expansion over time? Well, there were essentially two ideas. One, either the universe will keep expanding like this forever, constantly growing. Or two, the universe's expansion will slow down as gravity pulls against it, dragging the galaxies back together. Eventually, this could bring a halt to the expansion, causing it to collapse back down in some kind of big crunch, very similar to the ball falling back to Earth. So imagine everyone's surprise when a group of scientists in 1998 looked at distant supernova explosions from hundreds of millions of light years away from us to measure how quickly the universe was expanding hundreds of millions of years ago. And they found that the universe's expansion was actually getting quicker. This was a huge breakthrough, and the science team even received Nobel Prizes for this discovery. I mean, I even met one of the key authors of the paper, Dr. Brian Schmidt, back when I was 15 years old, and he was giving a talk on his work at a local university. I mean, this is a strange result, right? Instead of gravity pulling all of the galaxies in the universe together, it appears to be driving them apart. But how could this be? Well, this strange, repulsive form of gravity requires a new type of energy. This is where we get dark energy from, and it has some really strange properties. Unlike normal matter, the dark energy has negative pressure, making gravity repulsive. It's also said to make up 70% of the entire universe. That is a huge chunk for us to know so little about. And that's the mystery, really. What is this mysterious dark energy, and why is it making the universe's expansion continue to speed up? It is worth noting that this is a really wide open field. Some cosmologists believe that the answer might not even be dark energy at all. Maybe Einstein's theory of gravity is just wrong and requires some adjusting. An altered theory of gravity is a scary task because our current theory just works so well within our solar system. But hey, they said the same thing about Newton's gravity, and that got us to the moon. Now, I think this mystery, combined with dark matter, is the one that's the most unsettling to me. It's so strange how our laws of physics and basically everything we know only applies to around 5% of the universe. Spooky stuff.